Hello and welcome back to the 5.6 notes. This is the last section for substitution. Here's example 6 and example 7. The first thing I want to do in example 6 is identify that, what my u is going to be. I do notice that I am doing a definite integral. My numerator is x to the first, okay, and my denominator is x squared plus 1. Now, what I notice, trying to figure out what I want to choose for u, I need to look for something like a function and then try and identify where is the derivative on that function. Okay, so because I've identified this as a function and my denominator is a function and my numerator is a form of its derivative, then I'm going to use my denominator as my u value. So I'm going to come in here and I'm going to do, I'm going to let u equal x squared plus 1. Okay, I'm going to go ahead and find du dx as well while I'm over here, and I'm going to just write that as 2x. Okay, and then I'm actually going to go ahead and move my dx over to both sides, so I get rid of that. So du is equal to 2x dx. All right, now I'm going to rewrite my function here, and this is the integral from x equals 0 to x equals 4 of x divided by u and then dx. Okay, so the only thing that I need to get rid of is my x dx. Okay, that's what I need to substitute in to get rid of my variable x. So I almost have that over here. I have du is equal to 2x dx. So if I come over here and I divide both sides by 2, all right, then I get that 1/2 du is equal to x dx. So I can now substitute 1/2 du in for x dx up here, and I'm going to get the integral from x equals 0 to x equals 4 of 1/2 times 1 over u du. Okay, and I'll deal with that 1/2 later. I'm going to pull that out front. But I am going to go ahead and do method 2. I'm going to change my bounds and put them in terms of u. I find that to be the easiest way for me, but to each their own. So if you want to do it the other way, that's fine, but I'm going to do it using this. So when x equals 0, all right, u is equal to 0 squared plus 1, so u is equal to 1. So I'm going to rewrite what I've got down here, and I'm going to rewrite this as the integral from 1. Okay, let me come back up here. When x equals 4, then u is equal to 4 squared plus 1. So u is equal to 16 plus 1, so u is equal to 17. So now I'm going to come up here and write that this is 17. Okay, so the integral from 1 to 17 of 1/2 times 1 over u du. Now, I'm going to pull my 1/2 out. Okay, this is one of those instances when if you pull the 1/2 out and leave it out front, it'll save you a lot of time and a lot of effort. So let's rewrite this now as the integral from 1 to 7. No, I don't want to do that. I'm going to write 1/2 times the integral from 1 to 17 of 1 over u du. Okay? So if I were to evaluate this definite integral, it's going to give me 1/2 times the antiderivative of 1 over u is just the natural log of the absolute value of u, and that's evaluated at 1 and 17. Okay, so watch what I do here. I'm going to leave my 1/2 way out front, so 1/2 times the entire thing. I'm going to take the natural log of the absolute value of 17 minus the natural log of the absolute value of 1. Okay, now what we have to do here, the next step in this is to evaluate the absolute value. Okay, so this is going to give me 1/2 times the quantity. All right, the absolute value of 17 is just 17. So now my next step is to say the natural log of just 17. And then the absolute value of 1 is just 1. So minus the natural log of just 1. Now this part, guys, is 0. So we don't really have to worry about that. So then my final answer is just 1/2 times the natural log of 17. Okay? And you could even write that as the natural log of 17 over 2. Okay, however you feel, doesn't matter, which both the same thing. So, but that's it. That's the area under the curve. Okay, now that was me just changing everything to u. If you don't do this, if you leave your bounds in terms of x, you can still do that. Okay, I feel like if you put it into u, then your calculus and all this evaluation down here is a little bit simpler. But that's just me. Okay, so you guys can do what you want to do. All right, let's go ahead and move on to example 7. Example 7 is the integral from 0 to pi over 2 of sine to the 4th x times cosine of x. I'm going to rewrite this because it's kind of hard for me to read and to see what my u is going to be, but I'm going to rewrite this as the integral from 0 to pi over 2 of the quantity sine of x to the 4th times cosine of x dx. Okay, and what I notice about this is I have an inside function here, which is sine of x, and I see that I have the derivative of sine of x, which is cosine of x here. So that's what tips me off about what my u is going to be. Okay, so I'm going to do this. I'm going to say let u equal sine of x. Okay, then if I take du dx, that's just going to give me cosine of x. And I'm going to move my dx to the other side, so I end up getting that du is equal to cosine of x dx. Okay? So I'm going to come back up here and write my integral and do this. I'm going to do the integral from x equals 0 to x equals pi over 2. And I'm going to substitute in my u, so this is really just u to the 4th, and then whatever I have left, which is just cosine of x dx. Now, I need to substitute something in for cosine of x dx, and that's right here. I know that cosine of x dx is equal to du. So I'm going to substitute du back in over here, and this is going to give me the integral from x equals 0 to x equals pi over 2. And that's going to be from u to the 4th. And then I'm going to multiply that by du. Okay? Okay, then my next step is I want to change my bounds and put those in terms of u. So x equals 0 and x equals pi over 2, let's put those back into u. So when x equals 0, okay, u is equal to sine of 0. And sine of 0 is just 0. So u is equal to 0. Okay? And then when x equals pi over 2, u is equal to sine of pi over 2. All right, so I plug in x, find u, and so I get that u is equal to, what is that, just 1? So I change my bounds from 0 to pi over 2 just to 0 to 1. Okay, so let me rewrite my integral strictly in terms of u. And so I get the integral from 0 to 1 of u to the 4th, then du. Okay, and actually I'm going to make these bounds red so they make sure they're in terms of u. So we're just changing what we've got. Now this is something that we can evaluate. This one isn't too bad. So if we take our antiderivative here, that's going to give us u to the 5th divided by 5, and we're going to evaluate that at 0 and 1. And so as a result, I'm going to get 1 to the 5th over 5 minus 0 to the 5th over 5. And so the area that I get, guys, is just 1/5. Okay? So I think it's pretty simple, but it is a procedure. And I do this procedure the same way every single time. Okay, I ask the same questions, and I go through the same process. So if you're getting stuck on the process, you're getting stuck on doing this on your own, then I would go back and rewatch these videos, okay? And watch how I do them. All right, here's your homework. Please get started on that, and we will see you guys soon. Thank you.